Okay, my lunchtime is almost over, so I gotta hurry. Determine the exact value of the sine of pi over 4. Remember, pi over 4 is the same as 45 degrees. If you have to, draw out a picture. Draw out a picture, right? 45 degrees. This is a 45, 45, 90. If the hypotenuse or the radius is 1, then you divide by the square root of 2, which is the square root of 2 over 2 when you rationalize it for both sides. So the sine is the y value, square root of 2 over 2 to the right, square root of 2 over 2 up. It is the square root of 2 over 2. Memorize it. Find the numerical value of the tangent of pi over 3. Pi over 3 is 60 degrees. 60 degrees. So if this is 60, this is 1, then this is 30. There's my right angle. So from 1 to the short leg, you divide from the hypotenuse to the shorter leg, and then multiply by the square root of 3. The shorter leg times the square root of 3 gives you the longer leg. Now you want the tangent, which is the sine of pi over 3, divided by the cosine of pi over 3. So this is the square root of 3 over 2 divided by a half, which is the square root of 3 over 2 times 2 over 1. And that's the square root of 3. Okay, if you know your sine and cosine of that angle, you're good to go. Now this one had a diagram, but all they really told me in the diagram was that theta was pi over 3, and they want to know the sine of that angle. Well, the sine of pi over 3 I just wrote down. It's square root of 3 over 2. So those go pretty fast. Well, I'm making them go fast anyway. Now this one says, which of the graphs shown below? This one's got a lot of stuff going on. This got reflected, and there's a stretch of, so the amplitude is 2. The negative reflects it, and that pi over 4 shifts it to the left. So I'm going to get a really rough one here. Here's sine. And let's make the, or cosine, excuse me. Let's make this 1, this 2, this 1, this 2. And so this is going to be 1, and this is going to be pi over 2. Okay, so half of this would be pi over 4, because we've got to do that shift. Cosine, just cosine, looks kind of like this. Kind of like this dotted one. The 2 is going to stretch it out, so it's going to go up here, but it's still going to have the same intercepts there. And it's going to go all the way down here to the negative 2, so it's going to kind of look like this. We have to get a different color pen. Now, the negative, I'll use the pink. The negative is going to reflect this, so this point is now down in the x-axis. This is staying the same, this is staying the same. This low is now a high, and this high is now a low. Over the square of what's below. No, I'm just teasing. Alright, so now I get this guy, and then on top of it, they shift them pi over 4. So that's this distance right here. So right here, that's where this point becomes. This point over here gets shifted to here. I'm going to have to get a different color still. We'll use brown here. This point over here gets shifted pi over 2 to the left. This point over here gets shifted pi over 2 to the left. This point over here gets shifted pi over 2 to the left. So now your graph looks like this. And I'm thinking that there was one that was a lot more obvious than the other in the multiple choice. And I can't remember which one it is. I'll look to see if I have it handy. I'm sure I don't. Of course not, that would make it too convenient. I got papers everywhere here. Oh, there it is. It's answer D. Answer D. Alright, now, the free response ones, of course these are not going to be the same exact free response, but they might be similar. So make sure you understand how to do this. Now here you've got a sum from 1 to 16, it looks like, of that expression. Don't plug in all 16 numbers, plug the first one in. That would be negative 3 times 1 plus 12. Plug the second one in. That would be negative 3 times 2 plus 12. Even the third one, plug that in, negative 3 times 3 plus 12. All the way up to when you plug in 16, negative 3 times 16 plus 12. That way, you can see here that this is 9 plus negative 6, negative 9 plus 3, plus all the way to, this would be negative 48 plus 12 is negative 36. I can see that these are getting smaller by 3 each time. That makes it arithmetic. The sum, remember I gave you this to you before, is n times the first one plus the nth one, all divided by 2, n times that quantity. So if this is the 16 terms, I'm finding S sub 16 16, the first term, which was 9, the 16th term, which was negative 36, all divided by 2. Well, 16 divided by 2 is 8, and 9 and negative 36 is negative 27. So that's negative 200 something. What is that? Negative, let's see, that's a 6. That's negative 216, right there it goes. All right, now this one's got a little bite to it, because, and then you can see the space I have. This is x plus 4 times x plus 1. And that's nice because those are my other two factors here in the denominators. So that's my LCD. So I think I did this in green when I did these before. This is way back at the very first video. I'm going to multiply x plus 4 times x plus 1 times each one of these terms times 4 over x plus 4 plus x plus 4, x plus 1, I'm almost out of lunchtime here, times, this is 5x minus 3 all over x plus 4 times x plus 1, equals, one more time, hopefully I don't chew up too much space here, x plus 4. Every term both sides gets multiplied by the least common denominator here, times negative 12 over x plus 1. When I do that, you can see here that the x plus 4's cancel. I get 4 times the x plus 1 that remains. Here, everything cancels, except for the 5x minus 3. And then over here, this is kind of nice, the x plus 1's cancel. I get negative 12 times x plus 4. I say that's kind of nice because it's not going to be quadratic. I won't have to factor. Not that I don't mind, but it'll make things go a little faster. I distribute on both sides, combine like term, I get 9x plus 1 equals negative 12x minus 48. I'm going to add 12x to both sides. And I'm going to subtract 1. I'm going to kind of double up here because I'm short on time. 21x equals negative 49. Divide both sides by 21. And I get x equals negative 49 21st. I can divide top and bottom by 7. So negative 7/3 for my answer. And I don't have to worry about that making any of my denominators 0. Negative 7/3 is okay. Find the area of the triangle with side lengths 12, 15, and 25. 12, 15, and 25, you know all three sides, side, side, side. Okay, that was in the section of the law of cosines. This is Heron's formula. You have to find S, which is the sum of the sides divided by 2. You're going to have to memorize this formula. A plus B plus C divided by 2, so that's what, 52 divided by 2 is 26. And then the formula, the area, is equal to the square root of S times the quantity S minus A times the quantity S minus B times the quantity S minus C, where A, B, and C are the lengths of the sides. So that's S, it's 26, so this is the square root of 26 times 26 minus 12 times 26 minus 15 times 26 minus 25. Now I did this on a piece of paper somewhere. There it is. Okay, and of course this is the square root of 26 times 14 times 11 times 1, which is the square root of 4004. Now if he gives you a calculator, you can approximate that to about 63.3 square units, but if nothing else, you could, if he wants it in simplest radical form, you could divide this. This is 4 times 1001, so this is 2 square roots of 1001, which does not simplify anymore, square units. That's a peach. Got to know that formula. Got to know where S is. S, remember, is A plus B plus C divided by 2. All right, find the exact value. Well, the cosecant of an angle is 1 over the sine of the angle. And because I'm hurting for time, I'm not going to draw out a right triangle. I'm just going to, on the unit circle, I'm just going to go ahead and plug in that the sine of 2 pi over 3 is equal to 1 over, it's equal to the square root of 3 over 2, which is 1 times 2 over the square root of 3, which is 2 over the square root of 3, and I rationalize my denominator, which is 2 square roots of 3 all over 3. And last but not least, I can match the bases. 16 is a power of 2, 8 is a power of 2. This is 2 to the 4th, 2 times 2 times 2 times 2, 16, to the 2x plus 3. This is 2 to the 3rd, to the x plus 6. You have a power raised to a power. You can multiply the exponents. That's 8x plus 12, and that's 2 to the 3x plus 18. Well, if the bases match, you can set the exponents equal to one another. 8x plus 12 equals 3x plus 18. I'm going to subtract 3x, and I'm going to subtract 12 from both sides. Kind of lazy doing it all in one. I get 5x equals 6, divide by 5. So x turns out to be 6/5. You're not guessing that one. Alright, so you have to make sure that you can set this up and match the bases. If you can't match the bases, you're going to have to use logarithms, and that's probably going to require a calculator. Alright, so that last few problems pretty quick, but you can always rewind or just, give me a call, and if you have questions, I'll help you out, or maybe I'll be able to help you some before your exam. Anyway, that's it.